Uh, Good evening, students. So this is Somnath Patil from Chemistry Department. Today, just I am going to go for discussing the new topic from your 10th syllabus in chemistry. That is the topic name is acids, bases, and salts. So before starting, that is like individual concept. So just I will brief out what are the contents that has been included that is in this topic, and afterwards just we can go one by one. So now in this topic, that is they have given first what are acids, means like the definition, that meaning of the two acids, and some common examples, that is like which we are going to call them as acids. And in the middle they have given like what are strong acids, strong bases, and classification of acids also. Then later they have given some of the reactions of the silver acids with that is metals, and some other chemical reactions they have included. Then next, after that they have included some of the like what you can say properties. As I said, reaction of the silver that is acids with metal, how they will react, and with your oxides how they are going to react. And similar way they have included for your bases also, what are bases, then how that is like examples, what is the meaning of those bases, and then chemical reactions, some few reactions out of them, not all the properties or all the reactions, few reactions. Then next, after that they have included how these your acids and bases they will react with each other, and when they will made to react with each other, what are the compounds we are going to get. And next, that is they have given a concept, it is called pH. What is that pH, and what is the importance of this your pH, and that is measurement of this your pH scale. And for some of the important fluids, that is even like acids, what is the pH they have got, bases, and if the solution is neutral, what pH they have got. And for some of the common like solutions, like, or I can say even body fluids, juices, and the, as I said, body fluids means in the body we have got blood, some other this like components, what pH should have, that is like it is standard, that also they have been included. Then comparison of like your strength of your acids as well as bases. Then next part they have included, it is going to be salts, and related to salts. So using that your first, how you are going to get that salts, and using that salts, which are the compounds that we are going to prepare, which we are going to make. We have got so many compounds, but so they have included some like what you can say, some of the examples. That's why we will include only those examples. For example, that is like your baking soda, how you are going to prepare by making use of this your common salt, and so washing soda, then what are the uses of that compound, they have been included. So like that, some few compounds they have included that we can see at suitable time. Now let us move to first, that is I'll go with your what you can say, that is acids first, then followed by bases, then we can go with your salt. We'll discuss one by one. Let us move to, that is first part, that is with acids. Now, as all of you are aware or you have known, suppose if you see most of the acids, when you are going to like, if I'll say that is a taste wise, they will taste that is sour. That is these like acids, most of the acids you take, whichever you are going to come across, whatever the taste of those acids, they are going to be they will taste sour. And maximum, that is what you can say, metals, they are going to react with this your, when they will made to react with your metals, that is like acids. When you made them to react with what you can say hydrogen gas, then they sorry, just I'm correcting here, when they will made to react with what you can say acids with metals, then almost all the acids they will liberate hydrogen gas. I am repeating this once again. Most of the, that is acids, when you made to react, means when you allow them to react with your what you can say acids, they will liberate, they will produce this your hydrogen gas. Hydrogen gas. This is like one of the common property of this your what we can say are most of the acids they will exhibit this property. And next one is these your acids when these are like we are saying they are corrosive in nature means when they will made to react with some metals, they will react with that metal, they will consume, that is like here just I'm underlining, that is that they will eat away means they will make use of they will take away that metal, so that process they will convert into that other thing that is called that is corrosive. And these another property of this your acids is most of these acids, that is when you are going to check the formula of that is your acids, like molecular formula of that acids, they will begin with that is your what we can say this your hydrogen. Now here just I am going to take one example for this reaction, that is here this is that is like what you can say acid. Suppose if I that is name of this acid, as all of you are aware, this acid we are going to call it is hydrochloric acid. This acid name is hydrochloric acid. Acid name is hydrochloric acid. Hydrochloric acid. Now if you see whatever that is like most of the acid they are going to property just I have said. Now this taste we don't have here that hydrochloric acid we cannot taste because like sour they will be having the taste, but including that other whatever that effect they have got, we don't know, that's why we are not going to go with that one. Suppose if I'll go with the second whatever that is property, metals they will react with your acids and they will produce hydrogen gas. Now you can see here I have taken this zinc metal. When it is made to react with, that is like this is example for your acid which is that acid hydrochloric acid. Now what we are going to get, you can see here this is going to liberate this hydrogen gas, this is your hydrogen gas, it is going to liberate and it is going to form this your zinc chloride. Now as already I have said, one of the property of this your acid is most of the acids they will react with your metals and they will liberate or they will produce your hydrogen gas. Now this I illustrated here with an example. Now next, if I'm going to go with what you can do, this third characteristic, that is these acids when you start the chemical formula, when you are going to write, that will starts with your H. Now you can take here this example hydrochloric acid only. In this formula the first letter whatever it is going to start, it is going to be with your H. So this is like what you can say one example where we have like illustrated or we have like what you can say that is like justified like some of the most of the acid, like this is your hydrochloric acid, most of the acids here I took specific one acid, that example will be hydrochloric acid. With that I try to explain some of these out of nearly 3 to 4 properties, 2 properties as we have accounted. Now before going to that definition, actually just we have got like meaning of this your acids. So different approaches in the sense different scientists they have proposed different ways of defining your acids. Actually first time that is like one of the scientists by name, it is called Liebig is the name of the scientist. In the year 1838, 1838, so he has given that is like according to him what are acids means. So actually these acids are the substances when they will made to react with metal, they will made to react with your what you can say metal, then they will produce, they will like what you can say produce hydrogen gas. This is the definition which has been what you can say given by scientist name called Liebig, and it has been given in the year 1838. Okay. 1838. So what is the name of the scientist? Liebig. Leibig. It is the name of the scientist in the year 1838. During that time, as he has defined, what are acids? Acids are the substances which they will react with your metal, sometimes partially or completely, and they will produce hydrogen gas. So those substances, we are going to call them as what you can say, that is acids. Now, like that, we have got different approaches, different scientists, they have like what you can say defined, that is as what are acids. So out of them, that is one more way, just I am going to go with this one in this slide. That is according to Arrhenius. This is, that is like he has defined what are acids. An acid is a substance that produces, like already this I have said, that is like, now I am going with your another way of defining. This is your approach, which has been given by scientist name called Arrhenius. According to Arrhenius, when you take any chemical substance, when you add water to that substance, if in water, if it has got the capacity to produce what you can that is like H plus ions into the solution, then such substances we are going to call them as acid. When you take a chemical substance, just you add into water or dissolve into water, if they will split or they will produce what you can say H plus ion, then those substances we are going to call them as acids. Once again, here I have taken, that is like a same earlier example which I included in previous slide to according to Liebig, to explain that one what are acids. Here same hydrochloric acid. Suppose if I'll add this hydrochloric acid, if I'll add into water, that is if I'll make into dissolve into water, then this HCl, it will dissociate into H plus in water. It is in the in aqueous solution, that is like H plus and Cl minus. That's why this compound, that is a hydrochloric acid, we are going to call it is acid. So this is the concept. This is the concept which has been, this is according to Arrhenius. So any substance, when you add into water, if it has got the property of producing H plus ion, then those substances we are going to call them as what you can say acids. Now, moving to this next slide, here we have got, that is I have included some examples for, that is like some compounds which are going to be exhibiting, or which we are going to call them as acids. Amongst them, this is acetic acid. This is acetic acid which has got the formula, that is CH3COH. Next, citric acid, I have written directly that molecular formula, and this is going to be the next one, like a formic acid. Then this already it is repeated, hydrochloric acid. This everyone knows, this is like a formula for your sulfuric acid, and this is also going to be like another example for your what we can say acid, it is nitric acid. So these are some common acids which we are going to come across. I think now let us move to the next part. Now, that is these acids, whichever just I listed. Suppose if I will go back to that previous slides, here I have written nearly that is like total 6 acids. Out of them, that is we can categorize, we can classify these acids basically into 2 types. First category, we are going to call them as organic acids. Now, the first type of acids are organic acids. Now, what are these your organic acids? That is acids which are present in your what you can say, I am saying that is like living things. It may be that is in the plants, or it could be your animals. So these are going to be extracted or obtained from your living thing, that is like either from the plant origin or it is going from the animal origin. So such type of acids we are going to call them as what you can say organic acids. We are going to call them as organic acid. Now examples are this acetic acid and formic acid. We are going to call these are going to be the example for your what you can say that is organic acids. Now other type of acids we are going to have, those we are going to call them as what you can say inorganic acids. Now what are these inorganic acids? Acids which are obtained from, that is what you can say this your minerals, or that is like and from this your rocks. So that is those acids we are going to call them as what you can say inorganic acids. Now example for these type of acids are hydrochloric acid, this nitric acid and sulfuric acid. These are the example for your mineral acids. Now further, that is these acids, once again it may be your organic or inorganic acid. So it has been further classified into that is like what you can say concentrated, that is like acids as well as dilute acids. Further, now I am saying, here I am making it clear. First, under classification of acids, we have got organic and inorganic. Mainly, what are organic acids? Which are extracted, which are obtained from your what you can say living things. It may be plant or it is going to be animal origin. So such acids we are going to call them as what you can say organic. Whereas the like acids which we are obtaining, which we are getting from your what you can say minerals or from this your like of course rocks and all these things, then such acids we are going to call them as inorganic acids. Now once again these acids it has been further divided into concentrated and your dilute acids. So concentrated and dilute acids. Now what is the basis or what are concentrated acids and what are that your dilute acids? Now what is the basis for that one? Depending upon how much amount of that is like acid it is going to be present. Suppose if I'll take one simple example. Suppose if I have taken that is like a 10 ml. If I am taking an example, 10 ml of HCl, if I have dissolved in, that is like I made a solution that is like 100 ml. Now if I have got same like HCl, that is I have taken 5 ml of HCl in what you can say that is like same 100 ml. Suppose if I am writing this one, this is 10 ml, otherwise I will make right fine, this is going to be like in your 5 ml in same 100 ml. Now see here, volume is same, both it is going to be 100 ml only, but amount of acid contained in this first one, if I am labeling it as first and second, it is 10 ml in 100 ml, means like it is 10 ml acid and 90 ml will be water. Whereas this is 5 ml will be what you can say acid and 95 ml will be water. Total will be 100 ml. That you are supposed to remember. Now definitely based on these two, in the first case, how much is the acid contained in this one in 100 ml? That is 10 ml. Whereas in the second case, it is only 5 ml. Based on that one, I can say here that acid present in this one, it is going to be more compared to this one. Here it is 10 ml, whereas in this case, it is going to be 5 ml. Based on that one, I can say this acid, it is concentrated. Which one? 10 ml of hydrochloric acid in 100 ml. Whereas that is another container where 5 ml of hydrochloric acid it is going to be in 100 ml, that is going to be dilute. So this is simple way of what you can say accounting or explaining, that is further this your acids depending upon that is what you can say amount. Thus I am underlining this word, depending upon the amount of acid present in that given solution, we can classify or we can categorize these acids into that is maybe concentrated or it could be your dilute. Now here whatever the example I have taken here, out of these two containers, that is first one is concentrated, whereas second one it is going to be dilute. Now further, that is I can say once again this continuation of this your classification, strong and weak acids. Now here if you take an acid, that is how it is going to be determined, whether is it has got what you can say nature, is it going to be strong or it is going to be weak. So how earlier I said how we are going to say concentrated and dilute. So here strong and weak, what is the basis? The strength of acid is determined by that is how much hydrogen ions it is going to like what you can say provide. So suppose if you take that particular acid when you when you just observe it, when you check it, that is how many hydrogen ions, because already just I've said, according to Arrhenius, when you take a acid, just dissolve into water, add water, it is going to produce H plus ions. So those substances we are going to call them as what we can say acids. Now further, when you take like acids, if after adding into water, how many like H plus ions it is producing. Now if I'll take one example like this one, if I'll take these two examples, one is your hydrochloric acid, this is your HCl, and another one, it is going to be like your H2SO4. Suppose if you add this one to water, this one into water, it will produce us H plus and Cl minus. Now HCl produces one H plus and one Cl minus. When you go to sulfuric acid, after adding into water, it will produces H plus and SO4 minus 2. Now here it is going to produce 2H plus. Now you can see here, just the strength of an acid, whether it is strong or weak, it is determined how? By amount of this your hydrogen ions, that is like it is going to provide when it is going to be dissolved in your what you can say water. Now here it is producing only one, and it is going to producing what you can say it is going to be two. That's why like your comparatively both are acids. Sulfuric acid is stronger, whereas hydrochloric acid it is going to be weaker. Hydrochloric acid is going to be weaker, it is going to be weaker acid. So now this is, that is like classification of your acids like into, that is a strong and weak. Strong and it is going to be weak. Now moving to next point. So after knowing what are the acids, that is like according to Liebig, and another approach according to this your what you can say that is like Arrhenius, and classification into, that is different. First, the like I have given what are organic and inorganic acid. Next, constant among them, what are concentrated and dilute. Then next it is going to be what is strong acid and it is going to be weak acid. Let us move to next point, that is uh, how these acids, they are given in your syllabus some selected reactions. So definitely, of course, acids will have different or many reactions, but out of them, which are the reactions they have been included, so those we are discussing. Otherwise, let me go with first this your bases. Together we can have a discussion of this your reactions of acids and bases. Now let me go with next, that is like acids. Now I am going for now I am, before going to the next point, I am making it clear here. So now I defined what are acids and their classification. That's why first I am going with your after completing that like acids, I'll define what are bases. Then we can together discuss uh, reactions of this were acids and bases, acids and bases, because both these acids and bases, they can react with your metal. So some of the acid, they can react with only with specific reagent. So which are those? Just we can have a discussion, it is later. But let me go with first. Like acids, uh, if I have got a base in your like whatever previous classes, you might have come across some of the characteristic properties. So out of them, just have included some. Suppose if you say if substance is base means like acid, how I said in case of acid, it is going to taste sour. Here the taste of this your like whatever base, it is going to be bitter. It is going to have like a bitter taste. And when you hold or just to touch, that your what you can say acids we cannot touch, dilute we can touch, it won't be any problem, but concentrate we cannot. Same way, when you take this your substances which are bases, just to touch them, you are going to feel very what you can say soft touch. That is slippery. Maybe like if you have come across, if you take example of this your sodium hydroxide pellets in the laboratory, just if you touch it, you are going to feel it is going to be very slippery. So that is another property of this your characteristic of this your bases. And like your what you can say that is acids, these are also corrosive. And now in case of acids, just as said, they are going to their chemical formula, if you take for any acid, it is going to starts with H. Similar way here, in case of the your bases, when you write the formula of that your base, it will ends there. I have written in case of acid, it will starts with H. In the case of your what you can say bases, it is going to end with your OH, ends with your OH. So these are the some common or characteristic properties. Just we are going to say if the substance are even you have known at your whatever previous classes or in your lower classes. Now including this, you may be like if I it is very common or very simple test everyone knows. Suppose if I'll provide you two solutions, out of them one is acid and another one will be base. Just if I'll ask how we are going to say which among them which one is acid and which one is base, it is very simple. In the laboratory we are going to get this your litmus papers. Litmus papers. So just you take that is like a pinch of that solution, a drop of the solution. Suppose if you are applying a solution, and in the first, let me go with your in the case of this litmus paper, we have got two types. One is red and another one is blue. Blue litmus paper. Suppose if you take a drop, very small drop of this your like a solution, that is, and with the help of a glass rod, and put on that your what you can say red litmus paper. Suppose if it will converts into blue, then that solution is acidic. It is reverse. If you are blue litmus paper, if you are adding, it is going to be converted into red, it is going to be basic. So this is another what you can say simple test we can perform in the laboratory, that is to check that is whether that given solution or that particular chemical compound it is acidic or basic. So it is before adding into water and all those things, or making into reacting with your metal and all those things. Simple, all everyone aware, that is like you will get the litmus paper. So when you using that your these two litmus paper, just using a drop of that your solution, we can check it. That is whether the given solution is acidic or basic. Now let us move to the next point. As already in case of acids, just I said, after giving some of the properties, just I have defined that is what are acids. Now similar way with those basic properties or common properties, we can go for defining what are bases. So now bases are the substances when you add into water, when you place it into water, if they will produce what you can say this your hydroxide ion, that is OH minus ion into water, then those compounds are called as, or they are going to be known as what you can say bases. Now here if I'll take one simple example, this compound NaOH, sodium hydroxide, and you add into water, it will form Na plus into water plus OH minus in aqueous solution. Now that's why this compound, that is sodium hydroxide, its name is sodium hydroxide. So this compound, because after adding into water, it will produce us in aqueous solution, that is OH. That's why this compound, it is going to be called as what we can say base. It is going to be called as base. So the same thing, just we have written it over here. So this is also once again the same scientist by name Arrhenius, who proposed or who defined what are acids, the same scientist, he has given that is like meaning of bases. According to him, this is the definition. A base is a substance that produces, that has got the property when we add into water, if it will produces OH minus ion, OH minus ion, then that compound, those compounds we are going to call them as what we can say in chemistry, it is bases. Any substance, if it is going to produce OH minus ion after adding into water, or if it split into OH minus ion, then that compound we are going to call it is what we can say base. So this is one that type of example. Sodium hydroxide is going to be base. Now here just I have listed like your acids, some like what you can say common examples of your bases, which already I have included. This one, that is sodium hydroxide. Now this magnesium hydroxide has got the formula, this one, MgOH taken twice. Now this is also going to be example. This is also going to be example. This already, that is like formula in earlier slide just I have given. It is going to be sodium hydroxide. Sodium hydroxide. Now this is a formula for your ammonia, 10H3. These are the some common examples for your bases, like how I have given. I have listed for your acids in previous slide. Now, okay. So with this basic information or whatever this knowledge, just we can go ahead with. So we have now, I have given that meaning, what are acids, what are bases. Before that, some of the like common properties that will be shown are exhibited by both the your acids and bases. And next, afterwards, we have defined what are acids and bases, which has been given by that is your scientist name called Arrhenius concept. Arrhenius concept. So now let us move to that is they have included how these acids and bases, they will, when you subject them, when you made them to react with like what you can say some of the here especially they have included. I said already they have got very large number of reactions. So out of them they have given some of the examples. So out of whichever that is reaction, it is going to be included. First reaction is reaction of these metals when made to react with, that is either acid or base, then what will happen, or how in other way I can say, when you take this acid or base react with metal, then what will happen. So first let me go with your how this that is like what you can say metals reacts with your acid, or when acids are made to react with your metal, what it will happen. Now here I took the example of that is metal is zinc. So this is zinc metal, and acid I have taken it is sulfuric acid. Acid I have taken it is going to be sulfuric acid. When zinc metal is made to react with that is sulfuric acid. Now it is dilute sulfuric acid. Then what will happens? That is it will form this your zinc sulfate, and it is going to liberate. So this is hydrogen gas will be liberated. Hydrogen gas will be liberated. Now like this, another example, same zinc metal. Now instead of this your sulfuric acid, here I have taken that is like another acid. As this is like a hydrochloric acid, similar to sulfuric acid. Here what will happen? It is going to form zinc chloride, and it is going to liberate once again hydrogen gas. Now try to recall. Now only just before like this reaction, maybe like in the beginning, I said most of the metals, most of the acids, they will react with your metals and they will liberate, they will give hydrogen gases. So here, this is once again, that is under chemical properties also they have given how these acids, they will react with your metal. They will react with your metal and they will produce what we can say this is hydrogen gas. Here also just we can like cross check or we can verify whatever that beginning definition I have said. Now similar way you can take any, not only this one metal, because due to time restriction just we are taking only a few examples. So similar way, suppose if I am writing here one more equation this side. Instead of zinc metal, if I'll make use of this your metal sodium solid. when I'll take the same acid, sulfuric acid, H2SO4, H2SO4. Here, what we are going to get, that is, it will form this your sodium sulfate Na2SO4 plus it is going to liberate your hydrogen gas. It is going to liberate your hydrogen gas. Yes, I'll write it once again. Plus this is, and in chemistry, beside that your reactant or product, if I am writing this upwarded arrow mark, that is arrow mark, it is pointing upward. This chemical nature of this particular compound, you should remember, it is going to be in the gaseous state. Maybe in previous class, like related to chemical equations and reactions, sir might have given. And opposite, like reverse direction, down, pointing downwards, means that particular substance is going to be in the solid, like it is going to be in the precipitate form. Now here also, that is, this is not your balanced equation. Now you can make it balanced. Here you can make it is 2Na. Now sodium got balanced, sulfur is 1, oxygen Na2, this must be Na2SO4. Just to write this product properly. And oxygen is 4, sulfur is correct. Next hydrogen will be 2, hydrogen will be 2. This is balanced equation. Now here I have taken this metal is sodium, and I have kept that acid is going to be same, which I use for your zinc. So in this case also it is going to form sodium, like product will form by sodium sulfate, but it will liberate hydrogen gas. Now same way, if I'll take this your sodium metal, I'll use it with your HCl plus hydrochloric acid. Now here it is going to form, that is NaCl, and it is going to produce this your hydrogen gas. Now to make it balance, here you have to make here 2 moles, and here also it is going to be 2 moles. Now here it is going to be 2 NaCl. Now like this, you can list, you can go for taking any number of example, where, so I can generalize metals when made to react with your acids, they will produce your hydrogen gas. And depending, like here I have taken zinc, means zinc metal, zinc sulfate. If it is HCl as an acid, then it is going to produce zinc chloride. So similar way, I have taken one more example. Now, similar way, suppose if you, that is how these metals are in other way, like acids when made to react with your metal, how it is going to liberate hydrogen gas. Same way, what will happen when metals are made to react with your bases? Now here I have taken one example. Now the metal I have taken same, which I use for your acids. This is here zinc metal, and the base which I use, it is sodium hydroxide. Now whatever this compound we are going to get, it is called sodium zincate. The name of this compound is sodium zincate. So here there is no liberation of this hydrogen gas. When like bases are made to react with your metals, so it is going to, here I took the example of what you can say zinc. So it is going to produce sodium zincate. There is no byproduct. Similar way, now here, that is another, what you can say, reaction of acids. So these acids, when you are going to react with your, that is carbonates and bicarbonates. So what will happen? Or in another way I can say, when acids are made to react with your acids and bicarbonates, then what will be the reaction, or how they are going to react? So that is another chemical property, another reaction they have included. Now here, example I have taken, acid is in like what you can say hydrochloric acid. Example I have taken hydrochloric acid. Now this compound is called sodium carbonate, because now we are discussing how these acids will react with this your carbonates, and another one is with your bicarbonates. First, I am reacting, I am taking example of acid is hydrochloric acid. When they will react with your sodium carbonate, then what will happen? So when hydrochloric acid is made to react with your sodium carbonate, then it will produce us sodium chloride, and byproducts will be water and carbon dioxide. Now here once again, this carbon dioxide also it is going to be in the gaseous state. Now similar way, same hydrochloric acid. Now this is your sodium carbonate. Next, one more example. There is a difference in these two compounds. This is called sodium carbonate, whereas this below compound, its formula is NaHCO3, whereas sodium carbonate is Na2CO3. Na2CO3 we are going to call it sodium carbonate, whereas NaHCO3 we are going to call it is sodium hydrogen carbonate, or we can also call it as sodium bicarbonate. Sodium bicarbonate. Now, when sodium bicarbonate is made to react with hydrochloric acid, like sodium carbonate, remember it is also going to produce, that is what you can say, sodium chloride, and other byproducts are the receivers H2O and CO2, H2O. So I can conclude saying like this, both that is carbonates as well as bicarbonates as well as bicarbonates, when they will be made to react with your like acids, then what will happen, it will give salt, and it is going to form water, and carbon dioxide will be liberated, carbon dioxide. Now even this reaction you can check, very simple, that is a test in the laboratory also. What you can do, here you can take a glass test tube which is fitted with rubber cork with a bend glass tube. Now here you can take your that is this sodium carbonate, which is going to be in the solid state. Then here with the help of one more like that is like a glass tube, just you can add hydrochloric acid. When these two will react, that is of course the sodium chloride into water, it is going to be it is going to form here only, that is it is going to remain into the solution. Whatever this carbon dioxide formed, it is going to be in the gaseous state, it will come out. Now after adding HCl, you can close this one. Now here it is going to come this your CO2, which is going to be in the gaseous state. Now at the this like other end, receiving end, what we can do, just you take another that is a test tube, test tube, which is containing that is calcium hydroxide. Now we are going to call it is lime water, which is clear solution. Now it is colorless, almost clear solution here. Now after passing this your whatever this your gas into carbon this calcium hydroxide, what will happen? Now already I have written it here. This calcium hydroxide we are going to call it as lime water, which you have taken into this test tube. Now this carbon dioxide will be liberated over here, that you pass into this your lime water. Then this lime water, initially it is going to be what you can say clear solution. After reacting with your CO2, what will happen? It will form calcium carbonate, not carbon dioxide. It will form calcium carbonate, this limestone, which is like a solid, white solid. So here we will get some precipitate, some solid particles will be formed. So this indicates that when you react this your what we can say sodium carbonate or bicarbonate with acid, it is going to liberate this. If lime water, it will turns into milky turbidity, or like it is solid form, then it is going to due to the reaction between whatever this your carbon dioxide liberated by the reaction of acid with your sodium carbonate or bicarbonate, which turns lime water into milky. This is the chemical reaction. I have written it is there. Okay. Now this is like extra part, or it is even included in your textbook, that you can check it. How we are going to confirm that is this acids are made to react with your what you can say carbonates and bicarbonates, that is they will produce your carbon dioxide. Similar way, instead of this your what you can say hydrochloric acid, even you can try the reaction with your sulfuric acid. There it is only difference is, suppose if you want, you can try, just it is like your activity. So if I'll take same, this is your sodium carbonate, Na2CO3, it is a carbonate. Acid I am changing. Instead of hydrochloric acid, if you try with H2SO4, what is the product? What is the product we are going to get? We are going to get. Now that you can check it once again. That is like how instead of acid only have change. What is like a change we are going to observe? There is only this product change will be there. Other than that, everything it will be same. Everything it is going to be same. Okay. Now this is another chemical property or the reaction which they have included related to this your acids. What is that? How these acids they will react with your what you can say carbonates and bicarbonates, or when acids are made to react with your acids and carbonates and bicarbonates, what we are going to observe. Now moving to next. Another reaction which is that one means, so in case, so before going to this one, just I want to add here one more point. That is, they have included only the reaction of this your acids only with your carbonates and bicarbonates, not with your not the bases. Next, so what will happens? Already now we have discussed what are acids, what are bases, and one or two reactions of the silver acids and like bases. Suppose this compound already, that is we have known it is base, it is base, it is base. When you react with this compound is acid, hydrochloric acid, hydrochloric acid. So when acids and bases, now we are discussing acids and bases when they are made to react with each other, what will happens? Now as all of you are aware, this compound it is going to be sodium chloride. This compound is sodium chloride. Sodium chloride. Sodium chloride, and this is a like a formula for your water. So now when you take base react with your acid, then whatever this compound we have known, it is known, everyone it is aware, it is salt and water. It is a very basic or fundamental reaction where when acids and bases made to react with each other, what will happen? We'll get salt and water, and whatever the salts generally, I am saying they are going to be neutral. So that's why this reaction we are going to call it is neutralization reaction, because this is base when it is made to react with your acid, or acid when you made to react with your base, whatever we are going to get, that like a solution will be neutral. I am not saying like depending, sometimes if concentration of base and acid that is like same and they were same volume, when you mix, then that resulting solution will be neutral. But I am saying that compound form will be salt and water. If you take in general, even that is here we have taken one more equation. This is also acid. That is like here HCl we have taken, here sulfuric acid. Now base we have kept same. Now this compound is also salt. It is sodium sulfate and it's going to form water. It is going to form water. Now I can make a generalized statement that whenever acids are made to react with base, that is they will form salt and water, and that reaction we are going to call it is neutralization reaction. Neutralization reaction. Now today just I can stop at this stage. In the next class we can go with your like what are other that is like reactions which they have been included for your what you can say, that is like acids, as well as it is for your bases. If they have included some of the extra reactions, so those we can include, and even that is some one important concept also they have included, that is we can make out with the help of that is some even application also we have got. What is that concept? And in this part, acids and bases, if it is remained anything, any of the chemical reactions, so just we can discuss or we can include in the that is next class or in the tomorrow's class.